So you're solving logs, and you get a log with no base, and you need to find out what that equals. Well, remember, log with no base is the common log, which means log base 10. So you go to your calculator, plug in the type in the log button, and you get your answer. What happens when you get the natural log of a number? No problem. Most calculators have natural log, and remember, natural log equals log base e. But what happens when you get log base 3 of 18? Or log base 12 of 400, or log base 5 of 37, or log base 3 of 7/8. Do you know what power 3 is taken to get 18? I'm not sure. How about 12 to what power gives you 400, or 5 to what power gives you 37? Obviously, these are decimals, and most calculators can't handle these. So stay tuned to figure out how to handle these logs. Well, let's take log base 3 of 50. So 3 to a certain power will give you 50. What is that certain power? Well, we can write it in exponential notation. 3 to the y power equals 50. We're looking for y. But how do we solve for y? How do we get y out of the exponent? Remember your new properties of logs? First, if we take the log to both sides, the equation is still equal. And because we're taking the log of a value to a power, the power property takes the y down in here, next to the log. Now simply divide both sides by log 3, and there it is. Y equals log of 50 over log of 3. Now you might wonder, which log is this? Well, because it doesn't have a base, we're going to allow it to be the common log, log base 10. And how does this help us solve? Well, before we didn't have log 3 in our calculator, but we certainly have log base 10, the common log, and now you can plug these into your calculator, divide, and get 3.561. Let's try that again. Take the other example, log of base 12 of 400. That would mean 12 to what power gives us 400? Taking the log of both sides still produces an equal equation. And this log is any log of our choice. So why not make it be the most common log, log base 10? Because now we can use our calculator. Take the y out front because of the property of powers. Divide everything by log 12. And now we have a fraction that we can deal with most any calculator, most any scientific calculator. And the answer is around 2.411. This is called changing of the base in order to evaluate the log. One final example. How about log of base 3 of 7/8? That can be rewritten as 3 to what power gives you 7/8. Now, this shows you that you can use any log. You can take any log base to both sides, as long as it's the same log. So we can use the natural log if we wanted. No particular reason, but most calculators have natural log, so the natural log of both sides works just fine too, because you still get the y to move out front here. You divide out your ln3, and you get a fraction that we can solve with a calculator help. And notice we get a negative 0.1215. Just as a side note, it's negative because you are taking 3 and you're making it into a smaller number than 3. So you're having to reciprocate the 3 in order to get it down to a 7/8 result. So where do we use logs in real life? Well, you've all heard of the Richter scale, right? That measures the magnitude of an earthquake, or the strength of the earthquake. How much shake is there in the ground? The magnitude of the earthquake is not exactly the intensity. The intensity of the earthquake is given by I. I sub 0 is the intensity of a zero-level earthquake. You can read about that if you like. But here's the kind of problem that we're going to solve. Find the magnitude of the earthquake given the intensity of the earthquake. Notice the intensity is given as a multiple of I sub O. To do that, of course, we're going to use this equation. And we put in so the 12 million number, the intensity, goes in for the I. The I sub zeros cancel out. you end up looking at the log, which can be a log base 10, of the 12 million number, which produces a magnitude of 7.1 on the Richter scale. That was a big earthquake. Another application of the log is pH level. pH level, as you know, is the measure of the acidity or the alkalinity of a solution. The pH level range is between 0 and 14. 0 is the most acidic and 14 is the most alkaline. The formula for the pH is the negative log of H+. Now, H+ is the hydronium ion concentration in moles per liter of the solution. And that's not that important right now, but what we're going to do is take the H+ and plug it into this equation to find the pH level. Let's take orange juice. Orange juice has an H+ of 2.8 times 10 to the negative 4th moles per liter. Well, we put that number in for the H+ right here. I changed it to a decimal, and I took the negative log of that number, and it so happens that orange juice has a pH of 3.6.